Good.
We are resumed recording and you're good to go, Sean.
Okay, awesome. Thank you so much, Sean. Welcome everyone to the Identity Special Interest Group for July 25th, 2024. Thanks for hopping on the call today. Today on the agenda, we will go over our working group status updates and then hear a presentation from Stephen Curran on Trusted Web TDW, Enhancing DID Web. So looking forward to that. Since this is a Linux Foundation call, we're following the Linux Foundation antitrust policy. And as a Hyperledger call, we're also following the Hyperledger Code of Conduct. We're recording this call. It'll be posted on the meeting page and uploaded to YouTube whenever that works out. Let's see. Are there any introductions that anyone would like to make? Anyone who's new or rejoining or would like to say a few words about what you're involved in or interested in this space?
I would like to introduce Ciel. Ciel Recuerdo is a mentee contributor for Learning Tokens at our Learning Tokens lab, and she is very much interested in her postgraduate studies in identity. Ciel, if you want to say a few words.
Hi, good morning, everyone. So I'm Ciel. I'm currently taking my postgraduate in blockchain development at George Brown College in Toronto, Canada. So I like under Alfonso on he's my mentor at the Hyperledger mentorship program for the learning tokens. So there's like we'll actually have something with SSI integration for our project. So like interested on joining here and like also like doing some like research on like how we'll design it and do the integration part for that one. So yeah, but yeah. So prior to postgrad, I'm a software engineer. So like I'm from Philippines, but like I've worked in Singapore for like around 11 years, and then like I've moved here to Toronto last year. Yeah. So yeah, basically yeah, that's it.
Great. Yeah, thank you so much for introducing yourself. That sounds like a really interesting project, and we're so glad you're here.
Okay, thank you.
Yeah, thank you. Awesome. Let's see, any other introductions that anyone would like to make or announcements before we jump into our agenda? Here's the meeting page. If you would like to put your name under the attendees list, that would be great. All right. Unless anyone has anything else to add, we can jump into our working group status updates. I'll go through these pretty quickly so we have plenty of time for the presentation, but please feel free to jump in with any updates of your own with any groups that you're involved in or have attended recently. All right, so starting with the Indie contributors meeting, the Ubuntu 22.04 upgrade is coming along well. We are reviewing a new Indie charter document related to the change to Linux Foundation Decentralized Trust. The Indie Bezu work is also coming along. A new revocation PR came in recently, and they've been updating dependencies and documentation. So it's good to get those regular updates on that project. Let's see. In terms of the Aries working group, they've also been talking about the charter review and did TDW. Anyone attend that call who'd like to give a brief update? Let's see. Oh.
The most recent call didn't happen yesterday. We did have the call last week, and it was the charter.
Okay, awesome.
Yeah.
Cool. Let's see. Since you're off mute, would you want to I've got the notes here for the
Yeah.
areas collaboration Python user group meeting, but if you want to give a brief update as well.
Yeah, we're very close to release 1.0 of Akapai, so that continues to move forward. We had a second RC release candidate out. Talked about a new approach to AATH to try to make it easier to interact using the AATH with a mobile agent, and so looking at a new architecture for that. Patrick St. Louis presented a bunch of work he's been doing that demonstrates how easy it is to use Akapai with W3C VCDM and the test suites that are in the W3C community, which was cool. And then Daniel Bloom started talking about how we're going to get Akapai into did TDW into Akapai, which is did TDW is what we'll talk about later.
Yeah, awesome. Cool. Thank you for that update. Let's see. And then Anon creds as well. Sorry to keep picking on you, but would you mind giving an update on that one as well?
Yeah, so a new scheme is coming out of some work happening in Google and in Europe with CNL. So Anna and Jan is working with various people, Abi from Northeastern University, a bunch of people anyway involved in creating unlinkable ZKPs using hardware-based holder keys. So instead of going to BBS signatures, just using EDDSA signatures, which can be signed by or can be presented using hardware just in a mobile phone. So interesting work and looking at how we can move that forward quickly so we get both hardware-based holder keys and ZKP capabilities, so we don't have to go to simply using, issuing many credentials of many identical credentials or almost identical credentials, and then presenting them one at a time, or only once, to achieve unlinkability. So that was there. We also talked about the charter and Anon creds as well.
Cool. That's awesome. Yeah, thank you for that update. Let's see. Okay, those are our Hyperledger groups that we typically track in terms of the Trust Over IP Foundation. Let's see, all members met in mid-June. They had a presentation on the trust mining protocol and AI for authenticity. Let's see. As far as I know, the communications committee has not been meeting more recently, but let me know if I'm mistaken about that. Let's see. In terms of the governance stack, they met in late June for various conference planning and preparation tasks. They're also meeting today, so we'll report on that next time. The technology stack working group, they canceled their last meeting due to vacation season, but we'll meet again in early August. So you can see their updates here from June with their many various task forces. Let's see. Ecosystem Foundry Group, they had a presentation as well from about Project Relay ID, which is an open sandbox of digital identity development for aid distribution and information exchange. And let's see, concepts and terminology. They've been mainly working on the TOIP glossary and the terminology governance guide. Let's see, any more specifics that anyone would like to add related to any of our Trust Over IP groups?
Yeah, I'd like to add something really quick, and apologies if this has been mentioned to this group before, but during the all members meeting, a question was asked about the conversations that were going on between TOIP and DIF to merge them together. And it was noted that the decision was made that the groups were different enough that they were going to be kept separate for now.
Okay. Yeah, thank you for calling that out.
Separate for now, but under a broader Linux umbrella called Digital Trust.
Not true, actually. The
Oh,
digital
okay.
trust is an independent thing, and to my knowledge, neither organizations have made the decision to join.
Oh,
LFTT.
absolutely correct. Yeah, sorry about that. Yeah, we
So
have
it's under
the
Linux Foundation, but not Linux Foundation Digital Trust. It's
right.
more
So I
confusing than
think
it ought to be.
yeah. So DIF, I believe, is has joined as a observer member, and trust over IP. We're still figuring out what we want to do when we grow up. Yeah, but
Well,
you're right.
and by like
We have
observer
the
member,
option.
it's more or less saying we're sister organizations, but it doesn't mean a lot more than that. Because membership in
Yep,
LFTT
fair
means a
enough.
lot
Yep.
different than sort of being an associated organization.
Yes.
One more slight correction, Sam. You used the term digital trust, and it's decentralized.
Decentralized.
Decentralized. Yeah, I use
I'm
that
gonna
term
get in
too.
trouble if I keep saying that, so I'm gonna say it at the wrong
You
time.
will.
Danielle is gonna have my head.
I got in trouble once, so.
Cool.
Yes,
Awesome.
sorry
Yeah.
about that. Yeah, just folks should be aware that this decentralized trust is being established or rebranded under that, and we're looking into joining that in some capacity, as was stated.
Okay. Okay. Great. Thank you for those updates. And Sean didn't hear any of that. Okay. Great. Let's see. In terms of the Decentralized Identity Foundation, Sam, would you want to jump in on the DIDCOM spec working group and the users group updates?
So on the spec side, we are looking at the changes required for a post-quantum, post-quantum adjustments to DIDCOM. So we're beginning the work on DIDCOM next. I cannot emphasize enough that this is a very, very long process. So you should not be looking for the next version of DIDCOM to show up within like 3 months, and you shouldn't implement DIDCOM v2. DIDCOM v2 is the one you're going to want to target for a while, because it's going to take a long time to work out the rest of it. So beginning work on next version. So several years we'll have a new version, but don't count on it very soon. And then in the spec, or in the user group, there's been a lot of good conversation, including the using governance to validate the DIDs that show up in things you scan like QR codes. This means that you have no inherent trust, you never had, in something that you scan out of a QR code, and you can use governance mechanisms in order to make that happen. And so there's going to be some pending updates to the DIDCOM book that describes that process, why you should do it, and what it means to evaluate different things, with guidance about what you should do with a DID that you found that doesn't have anything. There are ways to establish trust without some external thing by requesting credentials from the user, but those are a little bit more complicated mechanisms that we'll be describing a little later. So there you go. That was our topics.
Cool. Awesome. Thank you so much. That's good to hear. Let's see. In the diff interoperability group, they met in mid-June and had a presentation on user adoption and interoperability. The Internet of Things Special Interest Group has not been meeting recently, as far as I know. In terms of the W3C standard, the credentials group had a trusted web presentation recently from Stephen as well, in addition to their other regular calls. Let's see. Cool. So that was, yes, Sean, go ahead.
Yeah, I was gonna comment on the Open Wallet Foundation.
Yeah, please.
I'm sorry. Yeah, so I apologize for not updating this section. I will do better for coming SIG calls. The Open Wallet Foundation has added a few new projects in the last few weeks, Trust Spanning Protocol being one of them. And as of yesterday, the currently named but soon to be renamed Begin Wallet coming from the folks at Cardano. Also, we had a fantastic presentation from the Republic of Ireland. They are using Credo and Ascar, Aries Ascar, and Open Wallet Credo for their European Union digital identity wallet implementation. I am working with the Republic of Ireland to get a presentation in this meeting and hopefully some kind of webinar for OWF in the coming weeks. It's summer in Europe, so that's going to be problematic. So it's probably not going to be until September, but we're working towards that. And the Safe Wallet SIG, which Daniel's a part of, has completed their Safe Wallet Guide. The TAC at the Open Wallet Foundation is currently reviewing that. And we are talking to the Credential Format Comparison SIG and the Wallets and Agents SIGs about not really relaunching, but working on coming out of the summer with some new planning and efforts in those two SIGs. So that's it for Open Wallet Foundation. For the next ID SIG call, I will make sure this is filled out in advance. Apologies to all.
Cool, thank you so much. Yeah, and if you have any of those links, I can add them to the page as well and add them to
We'll
our
get something
regular
in there. Yep.
rotation. Yeah, thanks. Brett.
So I have a question. Is the progress being made on an interoperable wallet? Is that what I'm understanding?
Right now we're working architecturally on this concept of the open wallet stack, which is something Brian has talked about, and I'll add that link in there. We currently have 2 growth projects, specifically Bifold and Credo. Credo is formerly Aries Framework JavaScript. But interoperability is something from an architecture perspective that we are prioritizing. But as of right now, there is no open wallet foundation project. There is no one project within the Open Wallet Foundation that will work with everything. So we are talking to all the projects about interoperability being something on their roadmaps and how we can, how these things can work together.
So how can our group get involved in that process?
Not to hijack this meeting, I'll put some links in for the architecture SIG, which meets every Monday, and I'll get some other links in there as well. Thanks for the question, Brett.
What about telecommunications architecture? Does that have a bearing?
Absolutely.
Okay.
It depends on how wallets would apply to that category, but yeah, we are interoperability is something that we're very concerned about, as well as being available to as many use cases as possible. Primarily right now, most of the Open Wallet Foundation projects are focused on identity. Begin, which I just mentioned, is a cryptocurrency wallet that's going to both expand the kinds of things that we can do, but also it means we need to change some of our processes and infrastructure internally from a security review perspective. And that's something Brian Bellendorf, who is our CTO, and I and Rye Jones, obviously, are talking about what our next steps are going to be. That project literally just landed yesterday. So, but yeah, I'll put some links into this wiki page.
Yeah, I'm not trying to hijack the meeting either.
I'm apologizing, not you. That was a good question.
Yeah, good.
Okay, cool.
But yeah, please drop it in the link.
Yeah, awesome. I can add those to the page, make sure those are around. Cool. I want to make sure we have plenty of time for Stephen's presentation. So I think that concludes our working group updates, and I will pass it over to you, Stephen.
All right. I did this similar presentation. These slides are updated because we've adjusted things since then, made tweaks to the did method. But I presented these a couple of weeks ago at the CCG, spoke way too long. So I'm going to go through quite quickly through some initial slides in confidence that people on this call would know about these things. So I'll just jump through this early part. So agenda talking about DIDs and DID methods, ledger-based DIDs, web-based DIDs, and why we're interested in these. And then a new DID method that is about trust DID web, about evolving web-based DIDs such that you can add more security and trust and verifiability into a DID web DID. And then some add-on, the bulk of it will be on the mechanics of how trusted web works, and then some other topics. So DIDs, decentralized identifiers, useful things so that a an organization, a person, a thing can have an identifier that they create themselves, they control, has a cryptographic key associated with it, so they can sign things, they can encrypt things, and they can demonstrate control over it. Lots of uses for it, issuing verifiable credentials, proof of control over an identifier, as I mentioned, using instead of or in combination with a centralized identifier. So an organization can have a DID that they use for signing things and so on, but it's bound to their own identity through a centralized identifier, so they can bind it to their legal entity identifier and things like that. Could also, for people, be replacement for things like email addresses and cell numbers. Serve the same purpose. An email address is a unique identifier for you in many contexts, but you could have many of them that you use in each different context. So DIDs, very useful things, as we found out. But right now, there are issues with DIDs. There are, the DID method provides the way that you use any particular DIDs, and there are currently 195, actually there's now more than that, DID methods that allow people to publish DIDs in a certain way and resolve those DIDs also in a certain way, and each one differs in the software you use to publish the DID and to resolve the DID, and that creates challenges in using DIDs. And so when DIDs started out, they started out on ledgers, and so there's this linkage between DIDs and blockchain and ledgers. So ledgers are super good places, and there's a whole bunch of points here on why it's really useful to put them on ledgers. You can't delete them, they're immutable, you can update them, you don't have to call to the owner of the DID, call home back to the owner of the DID to get the DID doc. All sorts of things that make them really powerful, but there's also challenges. Often there's cryptocurrencies associated with a public ledger, and that's challenging for things like where the team I'm on, government of British Columbia, can't really use cryptocurrencies, can't go buy some Bitcoin to root DIDs. Without a token, it's harder to operate. Who pays for it? Interfacing to ledgers can be hard. And so when there's probably 150 of those DID methods are related to ledgers of various types, blockchains and ledgers. Those are harder to connect to, or at least harder than a simple HTTP GET. So as a result, the use of DIDs has devolved to use DID web. So DID web is very simple. You simply have a DID that contains a domain and perhaps a subdomain and a path in it, and there is a textual transformation to convert the DID web to a HTTP URL that allows you to retrieve the DID doc. But there's no history. There's simply a path to the DID doc, and you get the DID doc, and whatever it is at the point you retrieve it is what it is. And so if you have to change your DID doc, evolve it, which is one of the main points of DIDs, the person retrieving it gets no history. They have no verification of that non-existent history. So who published that actual DID? Was it actually published by the entity that controls it, or did somebody else change it? Did they get hacked and their DID doc replaced? Obviously not immutable if you can just simply by updating a file on a file server, change it. And so there's not a knowledge of what it was before and what it will be in the future. So there's a whole bunch of reasons why DID web is challenging. Our belief is, and when we looked at the market and looked at the state of DIDs and DID method, there was basically 3 core DID methods in use today. Special purpose DIDs like DID key, and I should have included DID JWT, which is essentially equivalent to DID key. Those 2 types. those for simply wrapping a public key as a DID. Simple, but very, very limited. You can't have a lot of the features of DIDs with a DID key. DID peer, which we use in DIDCOM, which allows you to not publish them publicly, but just simply share them between DIDs and use them. And then finally, the only DID method that's really getting traction for published DIDs, for public DIDs, is DID web. Easiest way, you just put it on a web server. It really is almost, DID web is using a DID, but really it's the same as a PKI X509 certificate. It doesn't really advance the state of the art beyond that. And that's what we're trying to do with DIDs, is make them better. And then all the other DID methods, the 191 others are just looking for space. So we started this by saying there's not a sufficiently capable dominant DID method for public DIDs. So heck, let's create another one, because all the other ones are wrong, and clearly our ideas are the best, and let's create another one. So that brought us to this. There is a specification for this, so you can take a look at it. It's evolving minutely on a regular basis. This presentation evolved slightly from the one presented at the CCG, but Trusted Web, or Trusted Web if you say it fast, DID TDW is what the method is called. It's very similar to DID web, but with a ledgerless verifiable history. So there's a did.jsonl file right beside where a DID web's did.json file would be. And the L is not a typo. It is a means JSON lines is the data type, or the type of the log, and it is a log that contains a line for every version of the DID. So resolvers convert the DID into a HTTP address, same as they do with DID web, and then they retrieve the log and process the log to verify it and get the entire DID doc history. All of the versions are included. All of the versions are chained together in a micro ledger. All of them are signed by the DID controller themselves, so that in order to update the DID, you have to have control of the private key and be able to use it. Demonstrate its use, I mean. Self-certifying identifier enables uniqueness and portability. We have included in the DID method the handling, formalized how path to file, a DID URL handling is done. And we introduce as well the DID/whois concept, and I'll talk briefly about that. But DID/whois allows you to, given a DID, find out what attestations, what other people say about that DID. And that's a pretty important and cool feature. Very simple implementation, minimal dependencies, as well as some high security features that will enable its use in high assurance areas. So pre-rotation witnesses, binding to DNS, and so on. Chat is there. Oh, okay. I'll leave chat open in case people want to ask something or ask a question at any point. Okay, whoops. Okay, a DID TDW looks like this. This has changed slightly since the last presentation. This is the SCID. The blue part here is the self-certifying identifier. It now always follows immediately after the DID TDW and before the rest of the method-specific identifier. So DID TDW maps with this SCID, and aviary.id resolves to HTTPS aviary.id.wellknown did.jsonl. So notice that for those that have seen this presentation before, one of the recent updates we've made is the SCID does not always go into the HTTP address. So by default, it does not. So comparison to DID web, it's almost identical. Obviously, the did method name changes. The SCID goes away in a did web, and the JSON L, the L in the JSON goes away, but everything else stays the same. So this is very similar to what you know, did TDW and did web are very tightly bound to one another, and so it's possible that did TDW might even become a part of did web. It came about through a collaboration funded by BC Gov, Government of British Columbia. Brian Richter, Andrew Whitehead, and myself and John Jordan worked together on a lot of this, bringing in ideas from a lot of others. We did lots of looping in defining requirements, implementing, and then refining what we had. So that worked really well. Easy to implement, less than 1,500 lines of LOC in TypeScript and in Python, actually, and including pre-rotation support. We're continuing to evolve it. There'll be an announcement soon of where that is occurring. Right now, it's hosted by BC Gov, but that will be changing soon and moved into other organizations for incubating, and then off to presumably a standards organization. So I'm going to talk about the mechanics here. So here's where we get into just how it works. So first of all is the mapping. The mapping is exactly the same as did web. The SCID always appears as the third component of the did, and if it's not and it does not appear in the HTTP address. So if I've got did TDW issuer.example.com, issuer.example.com is the subdomain of example.com, and it's in well-known. If I'm using a path, example.com / the colons become slashes. So this one represents putting it into a path. And then finally, if you want, you can repeat the SCID in the did. So you put it in twice, and then it does appear in the HTTP address. So if that's important to you that the SCID appear, or useful to you that the SCID appear in the HTTP address, you do that by simply putting it in twice, once where it is required and once where it's optional, such as here in the path. So once you convert the did into an address, the did string into a HTTP address, you retrieve that and you get a did doc version. You get the did log and process it. Log entries look like this. 5 elements: a version ID, a version time, a set of parameters, and I'll talk about what those are, the state of the did doc, and I should change this to be did doc state, and then finally one or more, at least one data integrity proof on each one. Notice that this is a JSON array, and then there is a carriage return at the end of it. All of the unnecessary white space is removed to put it onto a single line, and then a carriage return put on, and then you get the next line. So version ID, version time, and so on is what each did lock entry looks like. This is an example of one, and I'll get more into it. This is the version ID. The version ID contains both the version number, a dash, and then an entry hash. And I'll talk about how this entry hash is, but this entry hash is generated across the entry, excluding the the data integrity proof. So the first 4 items, and this is how they get chained together. You get the date, the time. The parameters are here in blue, and in red is the actual did doc. So that shows what the did doc looks like. And then finally in yellow here is the data integrity proof, where the did controller signs the did and uses as a challenge the entry hash that is calculated up here. So we'll get into how those come about. So the parameters item, we'll start with that. It's a JSON struct with data about how to process the log. So this is giving the verifier instructions from the DID controller to say, hey, here's the structure of it. One of the important things is the version of the spec that's being used. That version, we're using DID TDW 0.2 is the spec we're using. And that defines what hashing algorithms can be used. So those are enumerated in the spec. What cryptographic algorithms can be used, those are enumerated in the spec. So that allows a long-lasting DID to, at some point, transition from using DID TDW 0.2 to 1.0, for example, a later version of the spec, and updates the various ways it gets processed. So for a long-lasting DID that may last many years, this allows it to evolve while still being opinionated on what it's allowed to use, so that it can so that you get interoperability. There is an authorized keys, update keys, and these are the things that are signed the data integrity proof. So notice that the keys that sign the data integrity proof that say this that say this is an authorized update, an authorized version. They aren't signed by a key in the DID doc, but rather signed by a key in the update keys array, in the parameters. We'll talk about more about that. The parameters in later versions can be empty if there's nothing changing. For example, if the only thing you're doing is updating the DID doc, but you're not actually changing the rules about how to process the DID, then it can be empty, and it can simply be an empty struct. Dependencies, light dependencies, JSON lines, which is a very simple spec that defines how the lines of the log are defined. We're using base 58 encoding. We're using multi-hash and only SHA-256 in the first version of the spec. In the current version of the spec, we're using multi-key for encoding a public key. We may or may not keep just the JSON patch. It's in there now. A JSON patch is used to transition a DID doc from one version to the next. We're debating whether we really want to do that, and this may go away in a later version. We are using JSON canonicalization scheme. So when we have JSON that we need to organize in order to hash it, we're using JCS. And finally, we're using a W3C data integrity proof using JCS and EDDSA for generating the signature authorization signature. So more mechanics, SCID generation. The SCID, the self-certifying identifier, is created from the first input entry minus the proof of the first version, the first entry in the log. And so what you do is you place a special placeholder, which is the literal string open curly SCID, close curly, wherever the SCID is supposed to appear. So it is put as the version ID value, and I'll talk about why that is in a bit. So it is always placed here. In the parameters, there is a parameter called SCID, and so it's always put there. And then in the DID doc, there is always at least one, the ID, where the SCID must appear as part of the DID string. And so it must at least appear there. So wherever the SCID is to be placed, a placeholder goes in. So you start with the entry as whatever you want. So the DID controller will set what parameters they want. They'll create whatever DID doc they want. They'll put the SCID, this placeholder for the SCID, in there, and then they execute this algorithm. They run JCS on the input. They hash that using, and then they multi-hash that using a particular hash algorithm. And that's it. That's the SCID. Previously, we truncated it but we recently decided not to truncate it. We also used base 32 because we were possibly putting it in the subdomain, but now that we don't have to do that, we're just using we're just using the full hash. And then once you do that, you then text replace the placeholder, this string, with the calculated SCID, and you get the first, almost the first entry. So these last 3 items are the last entry. We still have to mess around with this value here, the version ID, which is what we'll talk about next. So there is an entry hash that is chained to the predecessor on each calculation. So the first item in the log entry is version ID, and its value is version number. So 1, 2, 3, 4, 5 must be incrementing, must be an integer and must be incrementing, followed by a dash, followed by the entry hash. And the entry hash is calculated across the log, again, before adding the data integrity proof. For chaining, when we calculate the entry hash, we put either the SCID for that first entry, or we put the version ID containing the entry hash from the previous log entry. And that basically chains the first log entry to the SCID and each subsequent entry to the previous entry. So this is the thing that creates the microlog, creates the blockchain-like microledger. So for entry 3, we would have the version ID from the previous version, version 2, and that's why this 2 is here, and this is the entry hash of version 2. We've got our time, we've got our parameters. Here we're using the patch form of the JSON, where we say patch equals, and so this is a JSON patch from the 2 to the new version 3 of the did doc. So we start with that. We calculate the entry hash, again using just JCS on this input, and then multi-hash using whichever hash algorithm we're using, SHA-256 in the spec right now. And that gives us the entry hash. And then we update version with the new value containing the entry hash. So since this is version 3, this would become a 3, and this value would be replaced by the entry hash we calculated. So now we've got a linkage between the SCID, this self-certifying identifier generated off the first version, and all of the versions going along. So we've got that chaining. Finally, once you have that, you have the actual version of it, and you generate a data integrity proof across the current did doc with the version ID as the challenge. So you take the did doc, you generate a data integrity proof, use the version ID as the challenge, and signed using an authorized key. So for the first entry, that is one of the keys in the update keys. And for every other one, it is the update keys from the most recent prior log entry. So you can't both change the update keys and sign it in the same log entry. You have to sign with the previous keys to update the keys, and then from then on, those keys are used for subsequent. Once you have the data integrity proof, you add that as the last item to the log, append the log to the JSON lines file, and finally republish that file wherever it is supposed to go. So that is the core of it. Verification, you basically reverse everything I talked about there to verify it. You extract the data integrity proof, the authorized key, the did doc, and the challenge, and you verify the data integrity proof. You verify that the SCID in the first log entry is calculated correctly. To verify for every log entry that the entry hash is the appropriate thing, simply by reversing all you do. Verify that the did doc is aligned with the did, that the ID in the did doc is the same as the ID of the did, as the did itself. And then any other verifications based on the configuration settings in the parameters. And there are other verifications that are possible, and those are in the advanced features. So that's, this is what one looks like again. I did go over this, but basically you've got your version ID, your version number. Now the method makes more sense. Here's the SCID that appears in the parameters so that it's easy to extract. This would only appear in the first one, wouldn't appear in later ones. You've got your update keys that you can replace at any time. You've got this update key is actually being used to sign the data integrity proof. And so it is referenced here. Now, this is because this is the first entry, we're using this one. So it's in the same one. In subsequent ones, so in the second one would have to be signed by this same one, even if I'm rotating the key for authorization. And then I've got my did doc, and my did doc can contain, as long as it contains this did in it, this ID, it contain anything else you want to put in it. And that's it. So now I'm going to look at the log. I hadn't looked at chat. Can the SCID go into the URI? So you talk about it. Yeah, so they can go into the UI, the URI. So we basically decided we wanted to have it in a specific place and lock it in, and for compatibility with did web, even not use it in the HTTP. That's where our thinking got, but then we did allow for it to be put in any place. So you can still have them in the different places. So I hope that answers your question.
It kind of does. I worked it out in a comment. You don't have to read an answer to that. I've more or less worked out why you did this, which is to streamline the main case of one did per subdomain or domain, and even though it makes it more painful to put more than one did on a host, you can.
Yeah, but you could even put them, as I put it in there, you could even, like BC Gov could have a place for DIDs, and then one for energy and mines and one for citizen services.
Right, you use the path instead of the SCID, right?
Exactly, and you don't have to use the SCID in there. You can use the name of those. Yeah.
Right.
Cool. That's the basics. I'm just going to go over probably this one last slide and just summarize these. There's slides for each of these. These are just DIDs. So anything you put in a did doc you can use, and you don't have to do anything fancy with it. So there's no dependency on anything else of what can go in the did or anything. So these are just plain DIDs. The only thing, as I mentioned, is the use of the ID has to match. That's certainly a verification that can be done. There can be more advanced verifications on the did doc, but they're general purpose. The main did challenge not addressed by did TW that I mentioned about did web was you probably are calling home to get the did TDW. It doesn't have to be done that way. You could publish a did TDW on GitHub and it would work perfectly fine, and you'd be going to GitHub to get it and so on. So don't have to, but where you are publishing on your own website to take advantage of the fact that you're binding the domain to did, you would be calling home to get that with the, things like IP tracking and things that become possible with that. It's obviously very simple to publish a parallel did web. Basically, just take the did doc that you publish, replace in it the IDs, add an also known as for the did TDW, and then place the file right beside where the JSON-L file is as did.json. And now you've got both a did web and a did TDW. And as I say, there is talk, people have suggested that these actually just be did web, and that beside the did web, the did.json file for did web, you put the JSON-L, and now you've got both, but it's still called did web. So that's a possibility. Did/who is, just quickly on that, and this deserves a whole session, is this uses the diffs linked VP specification. Linked VP basically says a way to put a service into a did such that when you resolve it, when you resolve /whois, did/whois, you get back a verifiable presentation. That verifiable presentation must be signed by the did itself, and it can contain one or more verifiable credentials, and those credentials must have the subject of the did itself. And where you get magic there is that a did controller could get a did issued about its did from, say, Glyph, or from a registration of a legal entity, and put that into their whois. They could take a auditing certification that they've received from an auditor and put that in their whois. And now when they issue a credential using their did, the verifier of that verifiable credential could say, I don't know who this issuer is. Let me do a did/whois on this issuer and see who they are. Ah, I see that they are a business registered in British Columbia, and oh, by the way, they have a certificate from the Mining Association of Canada, and oh, they've got, you know, these other verifiable credentials that I understand, and therefore I can build up my profile of who they are and decide if I can trust the verifiable credential that they issued. They might be part of a did registry, a trust registry, and that trust registry has issued a credential to them for their did, and they put it in their whois. And now, without even having to consult the trust registry, simply by resolving a URL, what amounts to doing an HTTP GET, you can find that they're a member of a did registry via a credential issued by that trust registry. Portability, this has been an interesting one. We did want to include portability, and so portability means moving a did if you have to, and so portability is possible. We put some guardrails around it because people are saying, well, this could be a vector for loss of control of a did, claiming movement. So we've added some controls around that, so the did controller can choose whether they want to allow portability or not. We do have binding the did to DNS for higher assurance, and then other features, pre-rotation of keys, pre-rotation of authorized keys, and the use of witnesses, active other participants that witness the updates before they get published. And so those are features that are valuable to use for particular high security or high assurance scenarios. I can stop there. As I said, there's a bunch of slides in here about each of those topics, but I don't think we need to go through all of those. That is enough. With that, I'll stop sharing, and if anyone wants to ask any questions, open to that. All right, back to you, Shar.
Thank you so much for the presentation. I was curious about some of the guardrails around portability that you said were
basically
being
there's
discussed.
by default, portability is not allowed. There's a parameter called portable, true or false, and if you set it to true in the first version, it becomes portable. If you ever set it back, it becomes not portable and can't ever be portable, but that allows you to control that.
Oh, okay.
And that was based on a critique from some that said that's an attack vector, and it is a little bit. If you, particularly if you don't use witnesses and you don't use pre-rotation, portable is a bit of a risk. If you do use those two features, then portable is not a risk.
Okay. Okay, cool. Thank you. Awesome. Any other questions for Stephen?
And I'll add one more. Portable is only a risk if you lose your private key, if somebody compromises your private key. The challenge with it is they would only need to compromise your private key if you're not using pre-rotation or witnesses. If you're using either or both of those features, then they need to do more than just compromise your active private key.
Oh, okay. Okay. Cool, thank you. Let's see. Yeah, that was an awesome presentation. Thank you so much for joining us and walking us through all of that.
Thanks for having me. That was fun.
Yeah, let's see. Our next meeting, looking ahead to 2 weeks out, we will have a presentation from Sam Curran on the OpenID and DIDCOM work. So please join us for that as well on August 8th at the same time. Yeah, thank you so much everyone for joining and jumping in with lots of working group status updates and cool announcements. And thank you so much, Stephen, for the presentation.
Thanks, all.
So with that, we'll see you all in 2 weeks. Bye.
Thanks, y'all.
Thanks, Shar.
Bye.
Thanks, Tim. Thanks, Stephen.
Thank you.